Welcome back to the Deep Dive. We're here to cut through the noise on complex technical topics and give you what you need. Today, we're tackling something absolutely fundamental for CNC turning: picking the right tool post system for your lathe. And look, this choice really shapes everything. It's not just some minor feature. It kind of dictates your machine's speed, how flexible it is, and how much money it makes you. Get it wrong, and you're either stuck watching operators swap tools manually all day, which is a huge bottleneck, or, you've spent a fortune on a super complex machine whose best features just sit there unused. The sources we looked at make it pretty clear. If you're only doing really basic single cuts on small stuff, okay, maybe a single tool holder works. But honestly, the second you need more than one tool-facing turning, maybe a groove cutoff, you have to look at an automated multi-tool system. Otherwise, you're just not efficient.
That's exactly the point where folks seem to get tripped up. We see these two mistakes over and over, and they're costly. First, someone buys a simple lathe, thinking they're saving money, but then they bleed profit paying someone to constantly stop the machine and change tools by hand. Or the other way around, they overspend massively. They buy this complex turn mill center, a power turret machine, but all they make are simple little pins, total overkill.
Yeah, the tooling system really is the strategic heart of that lathe. So our goal today, let's simplify this. We want to give you a kind of shortcut to understanding the three main options: gang, standard turret, and power turret. And crucially, when to pick each one based on what you need: speed, complexity, the size of your parts.
Okay, let's dig in then. So that single tool setup isn't cutting it anymore. You need automation. What are the main ways to hold multiple tools? Right. When you move into serious production on CNC lathes, you're basically looking at three primary technologies. You've got the gang tool slide, the standard rotary turret, and the power turret. And it's really important to see them not as like good, better, best. They're different tools for different jobs, each optimized for a specific type of manufacturing challenge.
Okay, let's start with maybe the most specialized one: gang tooling. What's the deal with that setup?
Gang tooling is all about specialization for speed, mainly on smaller parts. You literally bolt the tools, maybe 4, could be up to 8 in a straight line, directly onto the cross slide. There's no rotation. Tool changes are just super fast linear moves, X and Z axis. Think of it like a drag racer. Stripped down, purely built for the absolute quickest cycle time on small, relatively simple parts.
Right, the speed demon for small stuff. So if gang tooling is the specialist, I guess the standard rotary turret is more the general workhorse.
That's a perfect way to put it. The rotary turret is your versatile all-rounder. It typically holds more tools, often 8 or 12, sometimes even more. That capacity makes it great for general-purpose jobs, things with a bit more complexity, or shops where the type of work changes often. Its key feature is indexing the turret spins around to bring the right tool into the cutting position. It gives up that raw speed of the gang setup, but what you gain is flexibility and more tool stations.
Gotcha. And then for the really complicated parts, the top tier is the power turret.
Exactly. The power turret, sometimes called a live tool turret, takes that versatile rotary turret base and adds another layer: milling and drilling capability. It still holds maybe 8 to 12 or more tools, but the critical difference is that some or all of those tool stations have their own built-in motor. This lets you use rotating tools, think end mills, drills, taps, right there on the lathe, so you can machine features across the part, like flats or holes, without moving it to a separate milling machine. This is what makes a modern turn mill center possible. It's pretty much essential if you're making complex components needing those extra features: slots, bolt patterns, cross-drilling, that kind of thing.
Okay, this is where it gets really interesting for me.
Yeah.
Because you set up this classic trade-off, right? Speed versus flexibility. Why would someone choose to give up the flexibility of a 12-tool turret? For a gang setup that might only hold, say, 8 tools, it seems limiting.
You make that trade only when cycle time is absolutely paramount, the #1 priority, and crucially, your parts are small and generally short. The difference boils down to that indexing time we mentioned with the turret. Think about it. Every time a standard turret changes tools, it has to unlock its clamp, spin the big disc around, and then lock it down again. Solidly. Even on a fast, modern machine, that whole sequence, it takes time. Maybe half a second, maybe up to 2 seconds, depends on the machine size and how far it has to rotate.
And half a second or even 2 seconds.
Fact.
That adds up incredibly fast if you're making thousands of parts.
Massively. Imagine a part needing 5 different tools. Let's say it's a 2-second index time per tool. That's 10 seconds per part just spent waiting for the turret. Not cutting, just waiting. If you run tens of thousands of those parts, you're literally losing days, maybe weeks of production time over the year just
Oh,
spinning metal.
Wow. And we saw that case study in the source material, the shop making those little aluminum spacers. They switched from a turret lathe to a gang tool lathe,
Ah.
and they cut their cycle time by almost 40%. That's just huge.
It's pure efficiency. With gang tooling, the tool change is basically just a blazingly fast move of the X and Z axis. Zip, zip. The next tool is already right there, fractions of an inch away. It's practically instantaneous. So if your business is high volume, repetitive work on small parts, the gang system is engineered to strip out nearly all that non-cutting time.
But that speed doesn't come free. There have to be downsides beyond just fewer tools, right? It sounds like you're really locking yourself into a niche with a gang lathe.
Oh, absolutely. You definitely sacrifice capability. First, yeah, the tool count is physically limited by how long you can make that slide. Second, and this is a big one for longer parts, gang tooling setups usually don't play well with tailstocks. The way the tools are lined up often gets in the way of bringing in that tailstock support. So if you need to turn a long, skinny shaft and prevent it from bending, you're pretty much forced back to a turret design. So yeah, when you buy a gang tool machine, you're essentially dedicating it to a very specific type of small part work envelope.
So the takeaway is, if you go for the specialist, the gang machine, you better be ready to also have a generalist, a turret machine sitting next to it for everything else that might come through the door.
That's generally the case, yes. It's a purpose-built asset. And we should also touch on setup complexity. Programming a gang tool lathe is often simpler geometry-wise, just X and Z moves. Programming a turret, especially a power turret with live tools and potentially a C-axis, that requires more advanced CAM software and definitely takes more setup skill and time.
Okay, that makes sense. Let's shift gears slightly. What about the cut itself? Rigidity, if you need to really hog off material or hold super tight tolerances, which system gives you more stability?
Great, rigidity. This is one where the answer might be a bit counterintuitive because the most rigid system actually depends on the part size and the type of cut.
Interesting. I think most people would just assume the big, heavy rotary turret, often weighing hundreds of pounds, bolted onto this massive machine base has got to be the stiffest.
And that intuition makes sense for heavy cuts. But let's look at gang tooling again, specifically for small parts needing high precision. In that scenario, the gang tool setup is often the king of precision. Why? Simplicity. It has fewer moving parts overall. There's no complex indexing mechanism to introduce potential play. And critically, the tools usually have much shorter overhangs. The cutting edge is physically closer to the supportive machine slide. That shorter distance creates a very direct, very stiff path for the cutting forces, which means less vibration, less deflection. So for tiny parts needing micron-level accuracy, that structural simplicity wins.
Ah, okay. So simplicity equals stiffness for the small stuff. But what about when you're doing that heavy roughing on bigger, tougher parts? Does the sheer mass of the turret system take over then?
It absolutely does. When you start taking big, deep cuts, especially in difficult materials like stainless steel or maybe titanium, the inherent advantages of that large, heavy rotary turret system really come into play. The turret's own weight, combined with how robustly it's designed and clamped, is specifically meant to dampen the significant vibrations you get from those heavy cuts. Now, it's true that a turret system has more components. The disc itself, the drive mechanism, the locking system, and each joint can potentially add up tiny errors, what engineers call tolerance stack up. But machine builders compensate for this. They use incredibly strong clamping forces and just rely on the overall mass and engineered stiffness of the whole turret and machine structure to handle high metal removal rates. A small gang slide just isn't built for that kind of punishment on a large scale.
Okay, so we've covered speed, flexibility, rigidity, but this tooling choice also fundamentally changes the machine itself, doesn't it? Like its physical size, how much floor space it needs.
Oh, completely. The tooling system is probably the single biggest factor defining the machine's overall architecture and footprint. Gang tool lathes, because they're simpler, tend to be remarkably compact. They only need space for that linear slide movement and the part envelope. They don't need all the extra depth and height you need to accommodate a big, heavy turret spinning around. This is a huge plus for anyone setting up manufacturing cells, maybe grouping several machines together for a family of small parts. We've seen examples like for making small connectors or medical screws, where you could fit, say, 3 compact gang lathes in the same space one typical turret lathe would occupy.
Right.
That space saving is a real tangible benefit.
Whereas the turret lathe, by its very nature, needs a much bigger box around it. You have to account for that whole turret swinging around, clearing the chuck, the workpiece, maybe a tailstock.
Exactly. Turret lathes inherently demand more floor space. The whole machine design has to allow for that turret's full rotation and its travel path, making sure nothing collides, even at the limits of its movement. This inevitably leads to a physically larger machine, often a wider base, maybe a longer bed, just to give the turret room to operate. And if you step up again to the power turret, the space and complexity requirements go up another notch. You still need all that rotational clearance, plus you need space inside the machine structure for the drive motor, for those live tools, the complex gear trains, and the encoders needed for controlling its position accurately.
That's a key point about the power turret, isn't it? It's not just about having a motor on the tool. That motor doesn't do much unless the machine also has C-axis control on the main spindle.
You absolutely nailed it. The C-axis is what lets you precisely position and rotate the main spindle, the thing holding the workpiece. It essentially turns the workpiece itself into another controllable axis, kind of like a fourth axis on a mill. Without that C-axis capability, your live tool can spin, sure, but you can pretty much only drill a hole or mill a flat straight across a center diameter. If you want to do true turn mill work, drill bolt hole patterns, mill complex shapes around the circumference, maybe engrave text, you need that synchronized C-axis control. And that means more complex and, yes, more expensive software and control hardware, plus the specialized skills to program and maintain it. It's a significant step up in investment across the board.
Okay, I think that brings us toward the end of this deep dive. Hopefully we've laid out a clear, kind of strategic map for making this really critical machine choice. Let's just quickly recap those three main choices one last time for everyone listening. You go with gang tooling when you need pure speed and high volume on small parts, but you accept you'll have fewer tools and limits on part size and tailstock use. You choose a standard rotary turret for its versatility and general purpose capability, accepting that small time cost for each tool index. And you step up to the power turret when the parts demand complex, multi-operation work involving milling, drilling, or tapping, understanding that this means investing in C-axis control and overall complexity.
Perfectly summarized. And the real key to profitability, the thing we keep saying, is just ruthlessly matching that tooling system choice to the kind of parts you actually make day in and day out. Knowing the strengths and weaknesses of each system, understanding when to specialize versus when to generalize, that knowledge makes you a much smarter buyer when it comes time to invest in new equipment.
Right. Now, we frame this mostly as specialization versus generalization, gang versus turret, but sometimes people trying to get the best of both worlds, right? We touched on this idea that some really innovative or maybe just ambitious shops actually mount specialized gang-style tool plates onto individual stations of their big rotary turrets. They kind of create a hybrid system. So here's something to think about. What kind of specific manufacturing problem do you think they're trying to solve with that kind of complex setup? What specific balance of speed, maybe tool density, and flexibility are they chasing there? Something to ponder until we meet again for our next deep dive.